Welcome back to Simplified Chemistry. In this video, I am going to cover the topic of empirical formula and molecular formula. By the end of this video, you should know how to determine the empirical formula from percentages and from mass. You should also know how to determine the molecular formula. I'll start by looking at the differences between molecular formula and empirical formula of compounds. I'll use benzene as an example. Benzene has a 6-membered romantic ring as a Lewis structure. The structure has got 6 carbons and 6 hydrogens. Typically in chemistry, we don't use Lewis structures. For example, when you're writing chemical equations, it is more convenient to use molecular formulas of compounds. The molecular formula of benzene is written as C6H6. A molecular formula must be consistent with the Lewis structure. It shows the exact number of atoms present in a compound. This brings me to the empirical formula. The empirical formula of benzene is written as CH. This shows that for every 1 carbon, there is 1 hydrogen atom in benzene. By definition, an empirical formula is the simplest ratio of atoms for the elements present in the compound. The ratio can only be written as a whole number. No decimals or fractions can be used in an empirical formula.
Here is an example of how to determine the empirical formula and molecular formula of a compound from percentages. Determine the empirical formula and molecular formula of an organic compound containing 66.7% carbon, 11.1% hydrogen, and 22.2% oxygen. The compound has a relative formula mass of 72. First, determine the empirical formula following these basic steps. Step 1, list down all the elements. Step 2, write down the percentages for all the elements. Divide the percentages with the relative atomic masses to get the ratio of the atoms. Step 4, divide through with the smallest value. The smallest value here is 1.388, and we get a ratio of 4.004 to 7.997 to 1. In this case, we have decimal numbers, but we cannot use decimals or fractions in an empirical formula. Therefore, we need to round off our numbers. We can round off 4.004 to 4 and 7.997 to 8. This gives us a simple ratio of 4 carbons to 8 hydrogens and 1 oxygen. Therefore, the empirical formula has 4 carbons, 8 hydrogens, and 1 oxygen. Now let's find the molecular formula of the compound. In step 5, sum up the relative atomic masses for all the elements in the empirical formula. We get a total of 72. Compare this sum with the given relative formula mass of the compound. The sum of the relative atomic masses in the empirical formula is equal to the relative formula mass. Therefore, the molecular formula contains 4 carbons, 8 hydrogens, and 1 oxygen. In this example, we will determine the empirical formula and molecular formula of chromium oxide, or the composition is expressed in mass. We follow the same approach as we did with the percentages. Work out the empirical formula following these steps. Step number 1, write down the elements in the compound. Step 2, write down the masses of the elements. Step 3, divide the mass of each element with the relevant relative atomic mass. Step 4, divide each of these numbers with the smallest number, which is 1.316, to get the ratio of the atoms. Here we get a ratio of 1 chromium atom to 1.5 oxygen atoms. But remember, we can't have decimals in the empirical formula. Therefore, we need to make 1.5 a whole number by multiplying 1.5 with 2 to get 3. But since this is a ratio, to maintain the ratio, we have to apply the same to the other part of the ratio. Therefore, we multiply 1 by 2, which gives us a final ratio of 2 chromium atoms to 3 oxygen atoms. Therefore, the empirical formula of chromium oxide is CR2O3. Now we have to use the empirical formula to determine the molecular formula of chromium oxide. To do that, we need to find the sum of the relative atomic masses for all the elements in the empirical formula. And in this case, it adds up to 152.02. Then we compare this sum with relative formula mass of chromium oxide. The sum of the relative atomic masses in the empirical formula is equivalent to the relative formula mass. Therefore, the molecular formula of chromium oxide contains 2 atoms of chromium and 3 atoms of oxygen.